Hi students, today our topic is parallel plate capacitor. Okay, first of all, consider two metal plates. Okay, consider two metal plates. These two are same in dimensions. Same in dimensions. Its area A, its area is also A, and separating distance between them is D. These two are separated by a certain distance D. Okay, this distance is very less compared to its area A. Understood? Its distance separating distance is very less compared to plate's area. Understood? Now these two are charged. How these two plates are charged? See, first plate connected to the positive terminal of the battery and second plate is connected to the negative terminal of the battery. It is positive terminal, it is negative terminal. Okay, here battery helps. Okay, battery helps. That means battery gives the energy to pull the electron from plate A. Okay, to pull the electron from plate A, and also that electron gives to the plate B. Okay, here battery gives the energy to pull the electron from plate A, so that electron is gives to the plate B. Okay, now after pull the electron, it attains the positive charge. After taking the electron, it attains the negative charge. Okay, this process is continuously running. After certain time, here potential difference between these two plates is equal to the potential difference between the two battery terminals. Okay, potential difference between these two plates is equal to the potential of the battery. That means here capacitor is fully charged. Capacitor is fully charged. So after fully charged, Q is equal to what is that one? CV. Okay, Q is equal to CV. It attains the positive charge, it attains the negative charge. Understood? Okay, after charging, here it attains the positive charge, it attains the negative charge. Understood? Okay, now electric lines of forces from positive plate to the negative plate. Electric lines of forces from positive plate to the negative plate. Understood? Okay, at the edges electric lines of forces are curved. At the edges electric lines of forces are curved. Inside the plates electric lines of forces are straight line. That means uniform electric field. Okay, that field is uniform electric field, but at the edges field is not uniform. So that's why lines of forces are bending. So that bending, here electric lines of forces are bending. That bending property is nothing but fringing. Okay, that effect is nothing but here fringing. Okay, at the edges lines of forces are bending, so that effect is nothing but a fringing effect. It is neglected. Why it is neglected? Why it is neglected? Because of its separation distance is very less than compared to plate's area. Okay, its separation distance is very less than compared to its area. That's why this fringing effect is neglected. Understood? Okay, you know, surface charge density is equal to charge per unit area. Okay, charge per unit area is nothing but surface charge density. Now consider three regions. It is the first region, this one is second region, this one is third region. Here 1 and 3 is in outside. 1 and 3 is in outside. Okay. Sorry, 1 and 3 are in outside. At the 1, electric field due to positive outwards. Electric field due to positive plate outwards. Electric field due to negative plate inwards. Okay. Here at the third region, electric field due to negative inwards, due to positive outwards. Understood? Okay. First of all, electric field intensity in outside region. Electric field intensity in outside region. Okay. What about that one here? Positive minus negative. Due to positive plate, due to negative plate. You know, electric field intensity sigma by 2 epsilon naught minus sigma by 2 epsilon naught. Due to positive plate, due to negative plate, totally 0. That means electric field intensity in outside regions is equal to 0. Understood? Okay. Consider in inside, due to positive plate outwards, due to negative plate inwards. That means due to positive plate, due to negative plate, both are in a same direction. Both are in a same direction. For our convenience, right here, due to positive plate outside, due to negative plate inside. That means both are in a same direction. Both are in a same direction. So inside, you take it inside, due to positive plate, due to negative plate, both are in a same direction. That's why you are taken here positive. Okay. So net field intensity inside sigma by 2 epsilon naught due to positive plate plus sigma by 2 epsilon naught due to negative plate. Total field intensity is equal to here sigma by epsilon naught. Total field intensity is equal to here sigma by epsilon naught. Are understood? Okay. You know, surface charge density is equal to charge per unit area. In uniform electric field, E is equal to V by D. E is equal to V by D. What is V here? V is the potential difference between these two plates. Potential difference between these two plates. D means separation distance between these two plates. Understood? Okay. E is equal to V by D. V here, these two values are substituting here. V by D substituting here. V by D is equal to sigma means Q by A epsilon naught. Okay. A epsilon naught is taking this side. A epsilon naught by D is equal to Q by V. You know, Q by V is equal to C naught. C naught means capacitance of a parallel plate capacitor. Understood? C naught is nothing but a capacitance. Capacitance is equal to here Q by V. Understood? C naught is equal to, you write as epsilon naught A by D. Understood? Epsilon naught A by D. Here medium is vacuum or air or free space. Understood? Here medium is vacuum or air. So C naught capacitance of this parallel plate capacitor is equal to epsilon naught. Epsilon naught means free space permittivity. Free space permittivity. A means area of the capacitor plates. Here main condition is two plates are having same dimensions. Okay, two plates are having same dimensions. D means separation distance. Okay, if in case you are taken rectangular plate. Okay, rectangular plates. If in case you are taken rectangular plates, so length and breadth. In this case, capacitance is equal to epsilon naught. Area means length into breadth by separation distance D. Understood? Area is equal to length into breadth. If in case you are taken circular plates, radius is R, separation distance is D, positive plate, negative plate. Capacitance is equal here, epsilon naught, area, pi R square by D. Understood? This is the parallel plate capacitor. Parallel plate capacitor capacitance is equal to epsilon naught A by D. Understood? Okay. See one problem. Okay. Capacitor has square plates, each of side L. Okay. Here given capacitor is square plates capacitor. Okay. Making an angle alpha with each other. This is the alpha. Okay. Then for small value of alpha, the capacitance C is. First of all, find out the mean distance. Opposite side. So it will write as L sine alpha. Smaller angle. So for smaller angles, sine alpha approximately equal to alpha. Sine alpha approximately equal to alpha. L sine alpha simply L alpha. This distance is as usual D. Understood? First of all, consider mean distance. Mean distance. Mean distance in one side D plus another side D plus L alpha. D plus L alpha by 2. First of all, consider the mean distance. Understood? 2D plus L alpha by 2. Now, 2D by 2 plus L alpha by 2. So, D plus L alpha by 2. D plus L alpha by 2. It is the mean distance. Understood? Capacitance. Formula C is equal to epsilon naught or C naught. Epsilon naught A by mean distance. What did one? D plus L alpha by 2. Understood? C naught equal to epsilon naught A by D plus L alpha by 2. Understood? Now C naught is equal to epsilon naught A L square. Why he are taken L square? Square plates. Each of side is L. Area of the square plate is equal to L square by here common one is D. Here taking the common D. Okay. L alpha by 2D. Here take the common D 1 plus L alpha by 2D. Epsilon naught L square by D. It is taken upon 1 plus L alpha by 2D whole power of minus 1. It is taken upon, so 1 plus L alpha by 2D whole power of minus 1. Understood? Okay. Epsilon naught L square D as usual. It is taken upon this one. Binomial expansion 1 plus x whole power of minus n approximately equal to 1 minus nx. Binomial expansion 1 plus x whole power of minus n is equal to 1 minus nx. Understood? Okay. So epsilon naught L square by D. Here minus 1 into plus minus L alpha by 2D. So its capacitance is equal to epsilon naught L square by D into 1 minus L alpha by 2D. Now its capacitance is equal to epsilon naught L square by D 1 minus L alpha by 2D. Okay, this one. See another problem. Charges Q1 and Q2 are given to two identical metal plates. Find the charge distribution on the four surface of the plates. Find the potential difference of such arrangement shown in the figure. Area of each plate is A. Okay, area of each plate is A and separation between the plates is D. Ignore fringing effect. Understood? Okay. So what is the required quantity here? Charge distribution on the four surfaces of the plates. Okay. And also potential difference. These two are required. Okay. You know already how to charge is distributed. So once again I will explain, with one example. Consider three plates. Okay, its charge is 2 microcoulomb. Its charge is 4 microcoulomb. Its charge is 4 microcoulomb. How the charge is distributed on the surfaces? First of all, taken total sum 2 plus 4 plus 4 microcoulomb by 2. What are done here? 5 microcoulomb. That is taken in outer surface of the first plate in left side, outer surface of the last plate in right side, 5 microcoulomb. Understood? Okay. Now here total only 2, but outer surface 5. 2 minus 5 minus 3 microcoulomb in inside. Understood? Here 4. 4 minus 5 minus 1 in inside. Understood? Minus 1 in inside. Okay. Due to induction, here developed one is plus 3. Okay. Due to induction, developed one is here plus 1 microcoulomb. Are understood? First of all, taken sum by 2, 5 microcoulomb. In outside 5 microcoulomb. In outside 5 microcoulomb. Here 2 minus 5. Or the inner side here minus 3. Here 4 minus 5 minus 1 microcoulomb in inside. Due to induction, individual charge is here plus 1 microcoulomb. Individual charge is here plus 3 microcoulomb. First of all, forget these two. Taken these two, 5 minus 3, 2 microcoulomb. It is satisfied. Forget these two. Consider only this one. 3 plus 1, 4. Okay, forget these two. Consider only this one. 5 minus 1, 4. It is satisfied. Understood? It is the charge distribution. Okay. In that manner, now these two are. Okay. First of all, Q1 plus Q2 by 2. Okay. It is the first plate in outer surface. Q1 plus Q2 by 2. It is Q1. Okay. It is Q2 in outside Q1 plus Q2 by 2. Understood? Okay. Q1 minus the charge. Q1 minus Q1 plus Q2 by 2. So LCM is 2. 2Q1 minus Q1 minus Q2. So Q1 minus Q2 by 2. That means inside Q1 minus Q2 by 2. Okay. Here individual charge in this one minus Q1 minus Q2 by 2. Understood? In outer surface q1 plus q2 by 2. In inner surface q1 minus q2 by 2. Okay. So in this case individual one is minus q1 minus q2 by 2. Outer as well q1 plus q2 by 2. See, if in case these two are added, q1 plus q2 by 2 plus q1 minus q2 by 2. So q1 plus q2 plus q1 minus q2 by 2. These two are cancelled. So 2q1 by 2. 2 do cancel q1. It's satisfied. Similarly here, this one minus q1 minus q2 by 2 plus q1 plus q2 by 2. Okay. 2 minus q1 plus q2 plus q1 plus q2. Minus q1 plus q1 cancel. q2 plus q2. 2q2 by 2. 2 do cancel. It is equal to q2. Understood? Satisfied this one. So charge distributed on the surface of the plates is on first plate outside q1 plus q2 by 2, inner q1 minus q2 by 2, this one minus q1 minus q2 by 2, outside q1 plus q2 by 2. Understood? Okay. First one is over. What is the second one? Find the potential difference of such arrangement. Potential difference is required. Okay. You know, in capacitors charge is taken inner surface of the positive plate, first plate. That means positive plate, inner surface of the positive plate. Understood? Okay. Here charge is q1 minus q2 by 2. V is equal to, what are one here? Charge q1 minus q2 by 2 into C. Okay, V equal to generally V equal to Q by C. What is the charge here? Q1 minus Q2 by 2. You know already. Okay. So charge on the capacitor means you consider only charge on the positive plate inner side, inner surface. Understood? Okay. Or C naught. C naught is equal to epsilon naught A by D. So student here potential is equal to Q1 minus Q2 by 2 epsilon naught A by D. V equal to Q1 minus Q2 by 2 epsilon naught A by D. It is taken upon. So D. Understood? Okay.